Hi, I'm Mike Serrano with Micron Technologies. We're here at Supercomputing 25 in St. Louis. I'd like to take you into our booth and show you a little bit about what we're doing and what we're showing here.
From silicon to speed.
First of all, as you know, we are a silicon chip manufacturer. We manufacture both DRAM as well as NAND. So what we're showing here today is our storage and memory solutions. This wafer is our 1 gamma, our latest process node technology for producing DRAM. Over here, you'll see our entire data center portfolio optimized for AI. It includes HBM3E, HBM4, SOCAMM.
Oh, sorry. Yeah. So what do you say? SOCAMM? Yeah.
SOCAMM, yeah.
Yeah. Please go ahead.
Oh, okay. As well as our more traditional DDR5 DRAM, or RDIMMs, excuse me, our high-capacity MRDIMMs, and our CXL, one of our CXL solutions. Right here next to it, you'll see this is a server from Supermicro. It is an Intel server with Micron technology memory in it. This server was actually the configuration used to set a new world record for the STAC-A2 benchmark. STAC-A2 is a financial benchmark. It is used for high-speed trading, risk analysis. And then, in addition to breaking a world record, a number of world records on STAC-A2, we recently broke a number of world records on STAC-M4. This is tick-by-tick analysis, again within the financial community, used by investment companies and hedge funds to leverage opportunities in the stock market. Over here, we have on display a chassis from Liquid. This is actually CXL. And what we've done here is, this is disaggregated memory. So it allows you, in this configuration, with all these cards were fully stocked, you could have 15 terabytes of disaggregated memory. So on each card, there's a CXL controller, and over here we have a XCON switch. So this 15 terabytes of memory can be shared amongst 4 different servers. So it allows you to pool memory very efficiently and leverage it for
how's the performance when doing what do you call it, like this, the memory this way?
So compared to a normal RAM, it goes from 100 nanosecond latency to 450 nanoseconds here. And it's 10 times that going direct to SSDs. So it's significantly faster than getting data off an SSD, and a ton more capacity than on-server memory.
20 times the performance.
Yes.
And for example, when you talk about the finance, if you have a system that breaks the speed record, you might make billions of dollars more than the one who doesn't have this system, because you can analyze the trades just a little bit faster.
Yes, and this is sitting around an Intel processor, so an Intel GPU with our MRDIMM solution. This allows you to quickly and efficiently evaluate market conditions. And yes,
it gives you an advantage.
A huge advantage, and you can, done correctly, this would pay for itself very quickly.
So it says up to 9.5 times higher user scaling performance, 89% reduction in response time. Big deal. So you have to design memory in a smart way to solve problems people have.
Exactly. That is absolutely key. It's not like it used to be where everything was pre-configured. Now you need to optimize your memory and storage to your application to really maximize the benefit of your system.
Because some of these SSD memories or the RAM memory is so fast, but if you just tweak some things, suddenly you can do new things.
Absolutely, absolutely. And shorten the time to insight or payoff and really benefit. So now you're finding that there's near memory. Let me see here, it'll come back up.
Yeah. So I guess it has a lot to do with algorithms also, in terms of being, like in general, to have redundant storage memory, like so it's safely in the system.
Yes.
There's a lot of things like that, right?
So hold on a second. It'll come up here in a second.
For high performance. Is this a video that's on your official channel?
No, this is our entire portfolio of memory for the data center.
So some of those parts you were talking about?
Yeah, so what you now have near memory, main memory, expansion memory. So it depends on the type of workload and how quickly you need to access that to get it in and out of your processor, your CPU or GPU, will determine what the configuration is. Because today, a lot of time and money is spent on the processor, and unfortunately, it sits idle a considerable amount of time because you can't get data into and out of it. So optimizing your memory configuration ensures that you're getting the most out of that processor investment.
So it's a big part of the high-performance computing world is how you design these memory systems, right?
Yes, yes.
And if we walk this way, so maybe on the other part of the booth, you might have a colleague talk about another part.
Yes, I'd like to introduce a colleague of mine.
Yeah, and he will talk about a whole different thing here.
Thank you very much. Let me get him.
Okay.
Hi, I'm Matt Wilkus. I'm a Sales Enablement Manager with Micron Technology. We're here at SC25 showing off our memory and storage portfolio. I'll show you what we're doing on the storage side for Micron. So right over here is our portfolio of solid-state drives that are really designed for AI and high-performance computing.
So what makes them special compared to other storage systems?
So a couple things. One we're showing right here is our Micron 9650. This is our PCIe Gen 6 SSDs in both the E1S and E3S form factors. So these are operating at 28 gigabytes per second random read speed and operating at 5.5 million IOPS. That's 20 gig per second. Sequential 5.5 random read speeds.
Did you say 25?
28.
28 gigabytes per second.
Yes.
So if I go on Amazon and I buy a Micron Crucial for $199, that's 1,000. That's 1 gigabyte. Is it?
Read speed, yes, yeah. The SSDs for data center are really designed for data center to have consistent performance over a variety of workloads. So you probably won't see this in your PCs anytime soon, but there's extra costs and you're paying for that.
25 times faster than the consumer grade storage.
Yes.
So it's, do all these supercomputer guys use this?
They do, or starting to. PCIe Gen 6 is really coming to its own over the next year or so. The sweet spot right now for supercomputing is PCIe Gen 5, which is the rest of these products that we're showing off here. Right here is a Micron 6600 Ion SSD. Neat thing about this is for high capacity storage. So it ranges anywhere from 32 terabytes to 245 terabytes in a single SSD. In fact,
are you saying
245 terabytes in a single SSD?
Can I have a look?
Oh, absolutely.
Can I hold it?
Oh, yeah.
So I have 245 terabytes right here. Okay, so my full life's work is on just 110 terabytes.
There you go.
So this is double of all the videos I've done the last 22 years.
We've hit your midlife right now.
So this is double of my 22 years of video, 8,000 videos in this little thing.
Yeah.
Is this the most compact storage in
This
the
is
world?
the most compact storage, yes, for this type of form factor.
All right. So who would be using this?
So this is going to be for AI data lakes, any large-scale hyperscalers. This is really starting to displace nearline hard drives. Because your highest capacity hard drive is roughly 30 terabytes. This is getting into, like I said, 245 in a single.
8 times more?
8 times more. So you're going to get, I think we're showing off here, the challenge for these big exascale storage. You'll be able to reduce the number of just physical racks by a 6x type of.
So what do we see here? What is
so
this?
that's the 122 terabyte. That is our smaller one. which is this guy right here, and the 245, which we're showing up before. Oh, oops, pulled the wrong one out.
All right.
There we go. Yeah,
So this is
so that's 122. So here's your life's work.
Can I hold this?
Sure, absolutely.
Nice. This is my career right here.
Yep.
122. I wish this was. Okay, so this little connector here, is it one of those 25 gigabytes per second ones?
Yes. Well, it's the new form factor of EDSFF. It's Enterprise Data Center Small Form Factor. So we're finally getting that transition for hard drives or for SSDs to now actually embrace being SSDs. Up until that time, we had like the U.2 form factor. It was looking like a hard drive. But there was really no reason for it to actually be like a hard drive. It was just the acceptance into the industry.
It's a 2.5-inch standard.
That is, yes. So, but now we're getting into the thinner form factors that take advantage of the fact that it's an SSD.
Does it need to be cooled?
These can be air cooled. There's enough surface area that at this speed, a PC Gen 5, it can be an air cooled product.
Is this like cutting edge 3D NAND? Implementation.
Yeah. Yes.
So there's like tons of 3D layers in there somehow.
Yes.
To achieve this capacity.
Yes. So, well, when you're talking about cutting edge 3D NAND, in fact, we got the wafer right here for you. This is our Micron G9 NAND. So each of these die is a 1 terabit die. So 8 of them is 1 terabyte of storage.
So I'm trying to.
Trying to get what the actual
I need to
breakdown
focus on
is.
it.
It's probably
you're
a
saying
half a
that
square centimeter.
Each of these little dots
is 1
terabit.
Terabit, so 128 terabyte, or 128 gigabyte.
Are they 3D?
Yes, these are all 3D. So this is, the stacking layers, it's over 270 layers that are stacked on top of each other.
It says world's highest performance NAND.
Yes.
2 TB QLC. What is this? 1 TB TLC.
Right. So it's 1 terabit capacity, triple level cell. Quad level cell is 2 terabit capacity. So basically, what we're doing is the TLC. We're storing 3 bits in a single silicon cell. QLC, we're able to store 4 bits into a single silicon cell. And so that's where we're able to double the capacity, or increase the capacity.
Those drives.
So these are QLC.
For example,
devices.
Let me just turn it here. Okay. Those, for example, that one.
Oh yeah.
So when I talk about storage for the enterprise, for example, they would use. You were saying up to 30 terabyte hard drives. Is this just going to be 8 times more expensive or a lot more? Like the price per terabyte. It would be nice if SSDs somehow, you know what I mean?
Well,
like
yeah.
if you could just buy one of these for the same price as 8 hard drives.
Right. Yeah.
It's not going to be like that.
But it's also, you're getting a lot more advantages of just price per bit. As far as space savings, cooling, and performance. The performance you're getting out of a solid state drive,
The performance
you get out of a solid state drive is orders of magnitude faster than a hard drive. So, here look at, again, talking about the 245, what you get for 1 micron 245 ion compared to the hard drives, it is, it's 6 racks less. So the cooling, the space, the amount of power consumed compared to a hard drive, there's a lot more than just cost per bit.
One other challenge, I guess, could be how many times you can write on it before the life is finished. What is the limit?
Yeah,
is there a limit that's very high, or?
So for enterprise drives, we have 2 versions of enterprise. Well, we have 2 versions of enterprise drives for our performance ones. The Pro, which does 1 drive write per day, so you can fill the entire drive up and erase it 1 time per day. We have the Max, we do it 3 times per day, write and erase. And again, when you're talking, and these are talking about 30 terabyte SSDs, you write 30 terabytes of data, erase it, and then write it again. You do that 3 times per day.
For how many?
5 years.
How many years can you do that?
5 years.
5 years.
Yes.
So for 5 years, 1 to 3 times per day.
Yes.
The whole
For the
122 or 245.
Well, for the 122 245, it's you don't have enough bandwidth to be able to write 245 terabytes into a drive in one day. So it is, we do terabytes written endurance. It's almost to the point that with these types of drives at this capacity, you're not going to wear it out because you don't have enough bandwidth just to even write and erase the full times.
So it's a question of bandwidth, but how reliable is the data still going to be there? Is there a system to scan the data? Is okay? Is that required? I guess these companies do it?
There's always, yeah, and I think what companies will do is they're not going to put like all their file on one SSD. It's usually striped over multiple SSDs. Again, now with the cloud, it's a multiple SSDs.
It's a RAID.
It's all it's well, yes, a RAID-ish type of
and here,
configuration.
There's a lot in one of these.
Yeah, that's 40 SSDs in there. So
when I go upload stuff on Google Drive, is it SSDs or hard drives?
It's probably two. It's probably both. Much like a Facebook or something or Meta, that initially it goes to SSDs because usually when you post something and you want everyone to see it to get that initial look, it's going to be pulling off of SSDs. At some point, it will get then archived into hard drives, which is like usually when you click on someone's photo on Facebook and it takes a while for it to actually come up, they're pulling off a hard drive versus off of SSDs.
And on the big wall here, you're showing US manufacturing?
Yes.
But you have stuff in Asia also?
We do.
To make all these, right?
Yes. So
Taiwan?
We do have, yes, manufacturing in Taiwan. Also in Singapore is one of our largest fabs. But also, something we're very proud of is being a U.S. manufacturer. So we do have fabs in Boise and in Manassas, and we're also building a large fab up in upstate New York.
So some of the other booths, they're talking to me about, they say that sometimes it's a memory shortage. Is there? What can you solve it?
It's interesting that with AI has really kind of transformed the whole computing industry and realized the importance of memory. So there is a big demand for memory.
Because they just want more and you need to catch up. More demand.
There's more, yeah. Everyone's trying to, meet that demand.
Come out with as much as possible, as quickly as possible.
That's the case right now. That's the case right now, yeah.
But when you show me these, it's kind of like mind-blowing to think what people might be doing with those.
Oh, I know.
And are the projects already deployed with these, or it's just like brand new and it takes time?
This is brand new. So yeah, these will really be ramping in the 2026 timeframe. These super high capacity SSDs.
Nice. What do we see
the last thing we're showing here actually is getting into PCIe Gen6, the next generation of bandwidth for just computing. This is a PCIe Gen6 server that uses 48 Micron SSDs connected up to the two Broadcom switches, then driving two GPU graphics accelerators. So
there are a lot of SSDs connected on one board.
So a lot of SSDs, they're using two switches to connect then to two graphic accelerators, the GPU accelerators.
Because the challenge is also always to get the GPU, the CPU, to get to the memory as fast as possible and back and all this.
Right. So one of the things that, in fact, we can kind of show it right here. Oh, just went away. Yeah. But this was configured with NVIDIA's Scale Acceleration Data Access, SCADA, as they call it. So basically, it's GPU direct storage. So with that capability, we're able to get 230 million IOPS out of a single server, which is pretty incredible. And the reason that's been able to be accomplished is because we're skipping the memory and the CPU. It's going straight from the GPU through the switches to the Micron SSDs and back. So the GPU can pull that information as quickly as possible.
Wow, it's just fascinating what's happening in this industry.
It really is. We're at
so much
such a cusp
processing
right now.
that needs to be done, but so many memories and they need to talk with each other.
Yeah, it's the memories talking with each other, and it's also the exciting thing right now is just the realization of keeping these processors fed. And you can spend a lot of money on a GPU or CPU, but if it's not getting data to it to do its work, it's that idle time is you're wasting money. So to be able to have fast memory and storage, to be able to keep those processors fed and keep the computation going has been really into Micron's strengths.
HDMI technology powers the global ecosystem of connected devices, enabling advanced displays that deliver immersive visuals and sound across entertainment, professional, and everyday applications.
As the preferred technology for digital AV connectivity, HDMI technology and the features and benefits it enables
Links billions of products worldwide, from HD TVs, set-top boxes, and laptops to gaming consoles, projectors, and audio-video receivers. It provides the reliable, high-bandwidth connectivity needed for today's ultra-high-definition video, lifelike color accuracy, and immersive sound formats. HDMI technology drives innovation across industries, including digital signage, medical imaging, education, and esports. With unmatched performance, interoperability, and scalability, HDMI technology continues to define how content is created, shared, and enjoyed around the world.